All right, now let's take a look at question number 4. Question 4, we're to find the area of the given triangle using two distinct formulas. Okay, so let's say we have triangle ABC as illustrated here. This side is 16, side B is 16, side A is 15, and side C is 12. Okay, now when I say two distinct formulas, you're going to be using the Sas formula. Let's list the formulas you're going to be using here. Formulas. You're going to be using the Sas formula, which is the formula area equals 1/2 AB sine C, or it could be BC sine A or AC sine B. And then you're also going to be using the SSS formula, also known as Hero's formula, which is area equals the square root of S times S minus A times S minus B times S minus C. Okay, where S is a semi-perimeter given by A plus B plus C divided by 2. Okay, so if you take a look at this problem, which of these formulas can we apply directly to this situation? Well, in order to answer that question, we have to determine what kind of situation we're dealing with. We're given side, side, and side. This is an SSS situation, so we're going to use formula 2 first. So let's use formula 2. Formula 2, the SSS formula. And then we're going to shift our attention to formula 1. Okay? So for formula 2, first thing we have to find is the semi-perimeter, so we can plug it into the main formula since we already know A, B, and C. So let's find the semi-perimeter first. S is equal to A plus B plus C over 2. So we apply this formula to this situation. We're going to have 15 plus 16 plus 12 over 2. Okay? Now let's plug that into our calculator and see what we get. We'll have 15 parentheses. Whenever you add in or subtracting terms, in the numerator or denominator, you must group them with parentheses or else you have a grouping error in your calculator. So group the entire numerator divided by 2. So 15 plus 16 plus 12 over 2. We use the semi-perimeter, which is 21.5. So S is equal to 21.5. Now what do we do next? Now that we have the semi-perimeter, we can now proceed to finding the area, okay? So the area is going to be the square root of S, which is 21.5, times S minus A, 21.5 minus 15, times S minus B, 21.5 minus 16, times S minus C, 21.5 minus 12. Okay, we'll enter this entire expression into our calculator. And let's see what we get. That should give us the area. Okay, so let's go ahead and do that. So we're going to have the square root. Be careful with your grouping here so that you are taking the square root of the entire radicand. Okay, so 21.5 times parentheses 21.5 minus 15 times 21.5 minus 16. Okay, let me start this all over again. All right, let's start over. Square root of 21.5 parentheses 21.5 minus 15 times 21.5 minus 16 times 21.5 minus 12, and then that gives us 85.4514. All right, so let's write this down. Our area 4514. Our area is area is approximately 85.4514. Okay, now that's that with formula 2, which is straightforward. You can use it directly. Now we're going to shift our attention to formula 1. Let's go ahead and find the area of the triangle using Formula 1. So Formula 1 is the SSS situation. I'm sorry, the SAS. Okay, the SAS situation. Okay, what makes this complex is that we only have three sides. In order for us to use this formula, we must determine the value of an angle. Okay, so we want to use 1/2 AB sine C. We can just go ahead and find angle C. Okay, so how can we find angle C? Find big C. This is a problem that's very similar to what we did, I think, in number 2 of this review series, finding the angular measure of an SSS triangle. When you deal with SSS triangles and you want to find missing sides, you have to make use of the law of cosines, okay? So we're going to use the law of cosines here to find angle C. The one that we are going to be using in this problem is C squared equals A squared plus B squared minus 2AB cosine C, all right? So let's go ahead and populate our measures. We have 12 squared equals 15 squared plus 16 squared minus 2 times AB 15 times 16 cosine big C. All right. Now we're going to do this as we did the other problem. Let's subtract these squared quantities from both sides. So I'm going to subtract 15 squared and 16 squared from both sides. Subtract 15 squared and 16 squared. And that's going to yield, and then using the symmetric property of equality, I can write this as negative 2 times 15 times 16 cosine C equals 12 squared minus 15 squared minus 16 squared. All right, so let's divide both sides by the coefficient of cosine C. Divide both sides, we're going to have divide this side by negative 2 times 15 times 16. And this side by negative 2 times 15 times 16. These two divide out. And we'll have cosine C, cosine big C, is approximately, now let's enter that expression into our calculators. So we're going to have, let's see, what do we have? 12, parentheses, don't forget to group your numerator in parentheses, 12 square minus 15 square minus 16 square. That entire expression divided by parentheses negative 2 times 15 times 16. Close that. Enter. And then we get 0.702083. Okay, so that's what cosine C is. Let's write that down. Approximately 0.702083. And then to get big C by itself, we'll take the inverse cosine of both sides of the equation. So we're going to have big C equals the inverse cosine of 0.702083. And let's see what that is with our calculators again. So the inverse cosine of our answer is going to be, okay, let me change the modes to degrees. Change the mode to degrees first because I reset my calculator. So change the mode to degrees. Enter, enter, enter. Okay, 45.4056. So big C is approximately 45.4056. Okay, so are we done yet? The answer is no. We want to find the area, right? So the area, using the second formula, we recall, is 1/2 AB sine C. So now we're going to put everything together. So the area is going to be approximately 1/2. A is, let's see, what is A again? A is 15. B is 16. Sine C, sine 45.4056. All right, so we're going to plug that into our calculator. All right, so when we plug it in, we're going to have, let's see, 1/2, 1/2, 1/2 of 15 times 16 sine of the previous answer we got. I'm going to enter 85.4514. So the area is approximately 85.4514. Okay? So since our two answers are the same, we are confident that our area value is in fact correct. Okay, but we can see the power of Hero's formula here. Even though it's ancient, it's really easy to compute the area of a triangle using Hero's formula as opposed to using the much more modern method of the law of cosines and 1/2 AB sine C as a consequence of the development of trig. Okay, so that's that for our review session. And thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel for other cool clips such as this. And please post a comment to let us know what you think about this presentation. More clips can be found on mathgoodserve.com. Thanks again for watching and have a wonderful day.